All right, now I'm just adding and subtracting the like terms, right? So the 8 and the 8, and then 2i and 2i, and the negative 5i. Now what's important is when you write a complex number, you guys remember from last week, you write your real part plus the imaginary. So the imaginary you always want to write next, okay, after the real part. So first, I want to add and subtract the 8 and 7. So 8 minus 7, 1. So I'm going to write that number first because that's the real part of the problem. The negative 2 plus, or minus 5 is negative 3i. Okay, and then that's it. That's all you can do. Now when I'm working on this one, okay, the difference here, let's make that more clear there. Okay, is I'm multiplying. Now remember, when you see that square, that means that this factor is repeated twice. So I'm going to have 5 plus 2i written twice. And now I have to multiply it out. Now you can FOIL this, multiply the first, the outside, the inside, the last. I like to set up the box, which does the same thing, just keeps you organized. So I write my factors on the outside. Remember, they go on the outside when you multiply. Go on the inside when you factor. And now I just multiply each one out. So 25 here, 10i there, 10i there, and then 2 times 2 is 4, and then I times I is I squared. Now when I write this out, I'm going to first start with that term, and then add up 10i plus 10i plus 4i squared. Now, there's an issue, and this is on me. It's my fault. Last week, when we talked about what this is equal to, I squared, I said, okay, if I have I times I, which is basically square root of 1 times the square root of 1, I told you that that's equal to positive 1, because negative is positive, right? However, when you multiply two square roots, the signs don't change. You end up with that same number inside. So I squared is equal to negative 1. So in your notes, and I'll show you where you guys are in your notes when I go over to my desk, you want to change that to a negative 1. I squared is negative 1, not positive 1. The reason being, if I had, let's say, square root of negative 3 times the square root of negative 3, that's equal to negative 3. Square root of 4 times the square root of 4, it's equal to 4. Okay, so that number inside, which is called the radicand, or just the number inside the root, if I multiply it twice, it just cancels out and becomes that number. Okay, so more of the story is that I squared equals 1, or negative 1 instead of positive. Okay, so now when I simplify that, this is actually 4 times negative 1. Not 4 times positive 1, which obviously now changes that to a negative number. So here I'll add those like terms, and I get 20i, and then it's the two real parts are 25 and minus 4. So now I have 21, the real part, and the imaginary part of 20i. Okay, so again, when you multiply, I'll set up my box, okay, and when I multiply I squared, that's kind of the key part of this, is whenever you get an I squared, change it to negative 1, okay? And everything kind of all falls in place. All right, so again, that should help you too with tonight's assignment, which on the back page has to do with imaginary numbers. Okay, so let's fix that in our notes right now. So I'm just emphasizing here in your guys' notes, this should be negative 1, not positive 1, like I said before. So over here, I erased all that and just put I squared equals negative 1, just so we can fix that. All right, so for Delta Math, the first problem right here for today, inverse functions. All right, so now inverse functions, which again, this is also in the packet tonight, you need to work backwards, okay? So let's take this problem right here, let's write this out. Okay, so I'm gonna take this right down on my whiteboard. Where's my little, oh, there it is. Okay, so if I have f of x and x plus 6, and it is asking me to find the inverse. Remember, when you write the inverse, you write the f of x or whatever this letter is, and then just put like a little -1. Treat it like this. Plug a number into the function, and then what would you do to simplify? And that's how you can figure out how to build your inverse. So let's just say I plugged in 2. My first step here would be to add 6. I do 2 plus 6, right? So that means I'm going to do x plus 6. That's my first step. So I add the 2 and the 6. Then the second step, raise it to the power of 3. So whatever my input is, I cube it. Okay, so 8 cubed, I don't even know what that is. It's a big number. Okay. You know that off the top of your head? I don't. 64 times 8.
64 times 8. 512.
512. All right. Okay, so 512. So, but that's not what I needed. What I needed was, what do I do to simplify? Now what I do to create the inverse is work backwards. Now I start with the last one, the last step. What's the opposite of cubing something? Not square root, but cube root. Okay, so cube root. So that would end up being my first step. And then what's the opposite of adding 6? Subtract 6. Okay, so my first step now is going to be the cube root of x, and then subtract 6. Now what's important with this is first I'm doing the cube root of the number. So don't put the adding 6 or plus 6, don't put it inside there. Keep it on the outside, separate. So in other words, don't do this. Okay? Because what that means now is that you're subtracting 6 before you cube root, because it's on the inside. But we want to just do the cube root first and then subtract 6. So we want to keep that separate, depending on what's going on. All right, so now with this delta math assignment, you got to just select the correct one. Okay, and there it is right there. So again, just working backwards with this. And it kind of explains how to do the inverse in a different way. The way that they do it is they actually just switch the x and y and then solve for y. Okay, so if you notice here, they go from y being here and x here, and they switch it, and now they solve for y and then work backwards. Okay, so you can do that way if you want to learn that way, but the way we teach it is just kind of recognizing how do you simplify it and then go backwards. Okay, now finding roots, okay, the kind of start of polynomials. Now when you see a polynomial, a lot of times it looks a lot like this. Some kind of graph that has curves. The one graph that you guys have been working with for a while that has a curve, or one curve, is a parabola, a U. But what if you start having multiple curves? All right, multiple turns. Okay, these are polynomials. Even a parabola is a polynomial, okay? So, but the first thing we want to recognize is, how do I find the roots of a polynomial? Okay, well, the roots, because that's what this question is asking for, is find the roots. Or what are the real solutions for when f of x equals 0? What are the roots for this? Anybody know? Mm-hmm. 1 is a root. Where did you see that? Like, how do you know it's a root? What do you?
Because it's on the one when it goes down to negative.
Right, it's touching what part of the graph?
line.
What is that line called?
The x-axis.
X-axis. What are points that touch the x-axis called? What's another name for that? Or something that crosses the y-axis. What are those points called?
Coordinates.
Okay, well, any point on a graph is a coordinate, but one that crosses the line or the axis is called a intercept. Intercept. Okay, right, x-intercept, or the ones that cross the y are a y-intercept. So a root is the exact same thing. So if a question asks you for what are the roots, it's literally asking you what are the x-intercepts. If it asks you what is the solution, if you look up here, it says what are the real solutions? It's literally the same thing. So solutions, roots, x-intercepts are all the same thing, 3 different ways to say it. The reason that they are in different names is because if I'm looking at the graph, it says x-intercept. If I'm trying to describe a function and like what it's all about, where it comes from, where it starts, where it ends, then I say a root. If all I did was solve an equation, let's say I give you this. X plus 3, and then let's say x minus 74. And I ask you, what are the solutions for that? What would you say?
X equals -3 and x equals +74.
Good. It'd be -3 and +74. You took those numbers, and then what'd you do with the signs? You flipped them, or you wrote the opposite. Same idea. Okay, so if I graph that, that means that this graph of that function would cross at those points. It would cross the line. Okay, and a lot of times what you're going to see, if I ask you to solve something, this won't be equal to y, this will be equal to 0. Because you're looking to see when is the function equal to 0. Well, when x equals -3 and when x equals negative or +74. And if you look up here, it says, when does it f of x or the function equal 0? Okay, so it's all tied together. That's the point of what I'm trying to make, is that it's all tied together. Now, how do you answer this? All right, well, first of all, Diego, you said that one of the roots is 1. What's another one? There's more roots. 3, what else? And -1. Now notice, every time I typed, I got a new box. The way I got that is by pressing the comma button. So every time I press comma, it gives me a new box. The other way I can do this on Delta Math is, you guys see this plus and minus button? I can just keep adding them over here with plus or subtract, okay? So that's another way that you can start writing more than one solution, all right? Now also notice this one in the middle, it doesn't cross through. It kind of like comes up and barely touches the x-axis, and then it comes back down. All right, that has a special property that we'll talk about. Okay, so that's all you're doing for these, is looking for where does it cross the x-axis? What are the x-intercepts? And you don't need to do this, like 0, actually it'll be the other way around, 6, 0, and then like this. I don't even think it'll accept that answer. Let's see if it does. And nope, it doesn't want that. So all it wants is the number. Just 6, and then -4. Okay. Okay, so let's go back. Now let's look at select the equation. So now what it's doing is it's asking you, tell me the equation based on what you see on the graph. And what we're doing is looking at the roots to determine that. Now let's go back here. You told me that if you see x plus 3 in the equation, that means that on the graph, it'll cross at -3. Or if it's -74 in the equation, that means on the graph, it goes through 74. So if I'm looking at this graph, if it goes through +6, what should I expect in the equation?
Wait, can you say that again?
If it's crossing through 6, +6, what are you going to see in the equation? Not just 6, but what else? What's going to be written for just +6? Well, hold on. Let me show you. So right here, on the graph for this one, it's going to cross through -3. But in the equation, I'm going to see x plus 3. Okay. So if it's crossing at 6, what am I going to see now? What do you think? X minus 6. So you're going to see the opposite in the equation. Now, what about 0? But what will you see in the equation?
You will see
So let's look at the options. So we know that one of them has to be -6. So we can cancel out these two over here because both of these have +6. So that means it's one of these. Which one do you think it is? If it crosses through 0, which one of those factors represents the solution for 0?
First one. First one.
Why this one? What part of that is this gives you the solution 0?
0. X is there, next to the
Yeah, the x, that first x right here. Because that x, the solution for just x by itself is 0.
So isn't it typically 1? Oh wait, no, never mind.
But then it'd be x minus 1. But if it's just x, because what these problems, when you're solving these, you have to say to yourself, what would I plug in to make this whole thing equal 0? So like right here, you would say, oh, I plug in a 6 right here because 6 minus 6 is 0. And then if I multiply that, and no matter what I multiply, as long as there's 0, it's going to be 0. Or like over here, look at these two, these ones over here. What would I plug in here to make that equal 0? A -6, because -6 plus 6 is 0. So what do I plug in here? Just 0. So that's why when it crosses through the middle of the graph, the origin, you should be looking for just x. So that makes this one correct. Okay, so let me clear that out. Okay, so let's do another one. All right. Okay, so how many solutions do we have here? How many roots? Solutions? 3. How do you know it's 3?
Because the way the shape.
Okay, so important question to answer. Which line does it have to cross through to be a root? Okay, so how many times does it cross through x? Right, you're probably looking at what else were you looking at? At the y, right? So it crosses through x 3 times. So what's the first solution? -7. What's another? -2 and? Okay, so for -7, what should I see in the equation? X what? +7. And then what about for -2? And then what about for +5? -5. Remember, just do the opposite of it, right? So which one is that? This one? Top right. Okay, so we got +2, +7, and -5. Okay, so that's how you look for those. Now let's see if I can get a special case that I'm looking for here. We did something similar to it. We did the opposite where I gave you this and then you had to come up with the equation. Now, this is a special case. First of all, how many roots are there? 2. Okay, what should I see for this first one? -2, what about the second one? -6, but notice how the graph comes down, touches it, but then it bounces back up. It doesn't cross all the way through. So you're going to see something a little bit different in the equation itself. So we should be expecting -2 and -6. Which one of those has the proper factors for it? Top left, top right, or bottom left, bottom right? Okay, top left has -2, -6, but if you look, it has x too. So that means it should have crossed through 0. It doesn't. Okay, does top right have all the right factors? Sort of, but what's weird about it? It has an extra x -6. The reason why is because it bounces off the graph. It bounces off the x-axis. So look how it comes down over here and then bounces off. Anytime you guys have something where it bounces off, or you'll get what's called a double root. So if it crosses through, it's a single root. If it bounces off, it's a double root, which means down here, you're going to see it repeated twice. Okay, so that's how you figure that one out. If it bounces, you should see two of the number repeated. If it crosses through, it'll be just one time. Okay, so this would be the correct answer. And what you're going to see in the next section right after that, you're going to get a bunch of those. See how it bounces twice? So that means, and remember when you repeat something twice, or repeat a factor, you can write it, how can you write it differently? With the square. And you notice all these answers down here have the square. So I should see a bounce or double root with what numbers? 4 and -2, so I should see x plus 2 and -4. Now is plus 2 -4, they're going to have a square on them or no? Yeah. So then we know it's going to be, which one? Bottom left. Because they're both double roots. Okay. All right, let's do one more. Oops, I clicked the wrong one. Okay, let me see if I can get, try and get a different one. These are both going to be plus. So be that one, right? Both double roots. Trying to see if I got one that both crosses and, oh, here we go. All right, so here for -7, should that be double root or the single root? Double. So I should see x plus or minus? Plus 7. Okay, I see that. And what about for the -2? So then I should see just what? 1x plus 2. So which one is it? Bottom left. Okay, so you guys at home, you guys see that? So if it bounces, it doesn't cross through, it'll repeat and you'll see the square. If it goes straight through, like here, then it's going to be just x plus 2 by itself, okay? And when you guys do the ed puzzle, Ms. Menard will go into more detail on that, okay? All right, so that is your Delta Math assignment. Now for the worksheet, what you're doing for part 1. For part 1, we're dealing with those same types of graphs, but we're making a table to graph it. Now remember, these are sketches, so it doesn't have to be perfect. What they want you to do is create the table first. And then you can see they already give you the x values. So your job is to plug in those x values and find the y. Now you can do this by hand. You could, let's say I take, sorry, what was your question?
You can enter this into decimals and work backwards, right?
Yep. Well, working backwards? What do you mean by working backwards?
Like, well, actually, never mind. But you can enter it into decimals and you can give you your x and y.
Yep.
You just input it.
Yep. If you
I
guys.
thought it was inverse, but.
And if you know how to make a table in decimals, you can do it even faster. Okay. So first, let's just show you how I do by hand, right? So the first one I had to plug in -2, right? So -2 here, and then -2 here. All right, and then I just simplify that. So -3, then square it, -1 there, square that's 9 times -1, -9. All right, so you could do that with each number, or go over to Desmos and basically do the same thing, just type it in. So now -2 -1, and then I square it, and then times -2 plus 1, and then there's my -9. Now, a fast way to go about this is you can like copy it like that or select it, copy it, paste it, and just change the number. Okay, and then there's my solution. There's my y value for -1, and then the next one was 0. So I just keep copying and pasting it. And then if I click enter, it'll take me to another line. Paste it, +1. There's my next number. And if you guys notice, there's a pattern forming. -9, 0, 1, 0. What do you think the next number will be? Let's see. So this would be positive 2 this time. Okay, it's going to be 3. So sometimes if it's a quadratic, that will repeat. But in this case, it does not repeat. Okay, so be careful with these problems. Just because you start to see a pattern doesn't mean it's necessarily going to have a pattern. All right, so then enter those values in. Another way to do that. Okay, what I do is I write y, I click 1, and I write out the function. So I do x, let's see, minus 1. Okay, then I'm going to put the squared, x plus 1. And then what I do is I go to the next line. And what's important, guys, is what I had to put a 1 there. And actually, right after the x, I also have to put a 1. Okay, so you always got to put a number right after. All I did, guys, I didn't do anything special. I literally just went next to the number or letter and click 1. And it automatically puts it at the bottom. Okay, you can always look back at this video too if you want to know how to do this. Then what I do is click plus and table. And up here, I change these to 1 so that they match. And then I type in those x values. Oh, sorry. Up here, let me start over. So what I actually want to do here is I do x1. So let me start over so I can start from the beginning. Go into Desmos, click on the plus, start with the table. So you don't have to like make all the equation first. You just go to the table first. Over here, I'm going to click on all those x values. And if you notice it recognizes it, I can just go plus and it starts making them for me, or just type them in. Up here at the top, I want to type out that equation. And if you look, I typed out the equation, but what's important is that the x has to match this x. So it has to be x1, x1. So I can make as many points as I want. It'll just keep doing it for me. Okay, so that's another way if you guys want to kind of get fancy with it. It's a good skill to know because then it makes it really fast. So, oh, just stretching. Okay, so you're basically, guys, you're just graphing those points and then doing your best to make a curve out of it. Okay. So I got all those points. Let's say, oops, let me get rid of this actually. Why won't let me delete it? Oh, there we go. Because I only have these ones. All right, so what you're going to do when you draw this is you start on the left. Okay, if it's positive, actually, in a matter of fact, I think a good idea for you guys would be to actually graph it. So get the points and then actually type this into Desmos. Because the reason I say that is because you have the points, but you really don't know like where to start the curve. Do I start below the line or above the line or what? So what I'm going to do is I'm actually going to go ahead and type out that function over here so I know what it looks like. And if you guys look, there it is. Okay. Another way you could do this, which it might be actually easier, and I just now remember Miss Menard does this too, is just type the function and then go to the graph. And if you click on any point, you can kind of just drag along until you get to that point. So there's -1, there's 0, there's 1, there's 2. So you can make the table, or you could do it this way, or do it by hand. All right, but now you know how to actually draw it. So when I go back to the homework, I know that down here I should start at the bottom and kind of come up, down, and up. So like on the graph here, if I was to go back to the actual assignment itself. Okay, so when oops, I'll clear all that. I know that I got to go up and down like this. Okay, I just want to go through those points. So at least graph it on Desmos so you know what it looks like before you actually put it on here. Okay. All right, down here. Now, recognizing polynomials. if you go back to the assignment itself in the packet, I added some notes down here because it says in here, review the math notes. And that's not on the packet, but I put it right here. And the whole point of this second part is recognizing what a polynomial is and what is not, okay? So a polynomial in general, you're gonna see something like this, where you see like a number, X, or any other letter raised to some number, and then notice the pattern, it goes 3, 2, 1. It starts to go down in order. So like this example down here, 7x to the fourth, it starts with the fourth, but then the second exponent is 3, then 2, then 1, and then nothing. Okay, so it should follow that order. If it doesn't, or let's say one of the exponents is negative, or let's say one of the exponents is not even a number, it's just some letter. That's not a polynomial. So here I have some examples of what is and what is not. Okay, the first one, that's a polynomial. Notice the pattern, 4, 3, 2, 1. And just remember the exponent on an x that's not written is a 1. Okay, so that's good. This next one, no. Because what's in the exponent? An x, a letter, a variable. But you shouldn't have a polynomial or a letter in the polynomial. I'm sorry, in the exponent. Okay, and let's look at what the graph looks like for that one as well. So the graph for that function looks like this. So this 3 to the x, it's flat, and then it goes straight up. This is called an exponential. And if you guys look at your homework, hint, hint, look at C, look at letter C. It's flat, and then it goes straight up. Okay, notice what E looks like. It kind of has that typical curvy looking pattern. When you see that, something has a turn, crosses the x-axis, you know right away that's a polynomial. Okay, and you could give a quick description of like, well, I noticed that it's curved and it crosses the x-axis. You can kind of write it however you want to do it, however you want to describe it. There's not like any like, special math terminology or verbiage that I want to hear there, okay? Even here, like if you look at letter B, those exponents are all positive and they're going in order. Doesn't have to be every number. It doesn't have to be 6, 5, 4, 3, 2, 1. You might skip 1 or 2, okay? But as long as they're all positive. Okay, look at D. D, I don't know if you guys remember what kind of function that is when it starts at some number and then just kind of shoots up off to one direction.
Are you asking or you're?
I don't know. Do you guys remember what that is?
Isn't that the square root one?
That is a square root. So that will look something like this. It'll be, let's say, square root of x, I don't know, minus 2, and then maybe on the outside like plus 3 or something. Okay, that, as you can see, if you look at the function itself, it's a square root. It's not a polynomial. Okay, you're expecting to see a variable raised to some positive exponent. Okay, now let's look at this one right here, or these two. The issue with this one is the first number here, that's good because it's coefficient, variable raised to a positive exponent, looks good. The second one, however, it's got those same, the good numbers are good on the bottom, but it's under 1. And because it's under 1, that's a rational. And I don't know if you guys remember this when we were simplifying before. I can take this part on the bottom, the x squared plus 5, and move it to the top. And what happens when you move it to the top is the exponents become negative. So if I move to the top, it looks like this now. And anytime I've got a negative exponent, not a polynomial. So that doesn't work either. Okay. All right, I want to stop there. So I don't want to take all the time here. But hopefully that was helpful for the assignment. And again, when you guys get to the backside, there's the inverse ones. where you just have to create the function. It kind of has a table laid out for you and you just have to fill in the steps. It's already kind of started for you. There's the imaginary numbers. Here, you're going to want to factor like we did last week and then solve. And then this one's more inverse functions, okay? All right, I'm gonna let you guys go. The guys that are online,